Let's talk about zero error. In this page of the notes, you will see the word zero error here. In case you don't know what it is, let me explain to you with an example. Let's say you want to measure the mass of the salt, all right, of a spoonful of salt. So what you do is you probably have a container which is a beaker, for example, to contain it. So you have a beaker with some sort of salt inside, and when you measure the mass, of course, you probably would use a electronic balance. Okay, so there will be a reading on top of it. So the reading, maybe say at the beginning it is 0, and then you simply put the whole thing there, then you make a mistake because you are also measuring the mass of the beaker as well. So normally what we will be doing is we will want to simply put the beaker on top of it, and of course you may have a reading of maybe 100-ish gram probably, but then what you can do, you have to press a button called set 0, and then after that your reading obviously on the electronic balance will become 0, and then you can then add the salt onto it, and then you can get the reading which is accurate. So zero error actually is referring to the times where when you try to measure anything that doesn't actually start from 0. So other than my example here, it could also be the fact that when you have the beaker, before you add the salt, it may not be exactly the mass of the beaker, but maybe just slightly off by maybe 2 gram, etc. Maybe you just switch to another beaker, but they may not be exactly the same mass. So maybe that's why it's not exactly 0. So these are all zero error. In terms of the length, you may also have it. In our example here, you may want to read the question, but what it means basically is in part A, if you remember the micrometer we talked about in the last video, you will start with the micrometer when it is tightened, right? When it is, as in like at the beginning, the two sides of the micrometer will be tightened together. So that means there's nothing, literally nothing here, not even air between them. But then the reading sometimes, because of the mechanical issue or calibration issue, it may not be exactly 0. So there's no set 0 button you can do. So what you can do is that you can just think about when you use a ruler. Actually, just like the example below, what if you really have to measure the metal rod like this? Think about it. What you can do, obviously, is you can see the reading here will be how much? 5.6, right? And the reading here is 1.0. So obviously, you are not going to say the length of this metal rod to be 5.6 because we only start from 1. And let's say we can't do anything because obviously you can see this end of the ruler is somewhat damaged. All right, and by the way, I think this is something that we want to remind you as well. When you're in the lab, usually people what would like to do is with the meter ruler is they somehow like to play Star Wars or whatever, or try to play I don't know what kind of game, role play or something, and you put the ruler on the floor, etc. And you kind of damage the edge of the ruler. So that actually makes us difficult because in that case then we cannot really use it. So that's why maybe sometimes it may be better for accurate measurement to start with maybe say 1, or if you really have a long one, I probably will start at 10, just easier for calculation. So in this case, obviously what you do is 5.6 minus 1.0, and in that case you get 4.6, which means 46 millimeter. Okay, so that means this example with the micrometer should also be the same. So I will want you to pause the video, try to take the reading and find out the exact length for the object.
A few moments later.
Okay, so basically you have to take the reading from the two pictures. So for this one, I believe is 0 point something because I don't see another line that is vertical. Horizontally, this line should be 10 plus 2, so 12, so I believe it's 0.12. While for this one, you can see this is a bit different from our simulation, by the way. You can see that this is 10, this is 11, and you can see in the middle this should be 10.5. So for ours it will be 15 0.5 plus the horizontal reading on the drum scale. So these would be, well, 12 also, so 0.12. So that means this is 15.62 and this is 0.12. Oh, actually, it's very easy for calculation. So that means the actual length will be 15.62 minus 0.12, and that is 15.50 simply in terms of cm, I believe. One thing, however, I would like to emphasize is that you may put down 15.5, so without the 0. However, I would say you should put down the 0, because this 0 actually is telling the other people who try to take or read your measurement to know that, hey, my measurement or your measurement is up to this decimal, because there's a difference between 15.5 and 15.50 in physics. In maths, I know it's exactly the same, but in physics, they have the different meaning. For 15.5, probably you have an uncertainty of 0.1. For 15.50, you may have an uncertainty of plus or minus 0.01 instead. So this one will be much more precise. Alright, so in this video you learned about the idea of zero error, and remember this concept can be carried to other dimension too. So not only the length, it could be mass, it could be time, it could be anything that you measure with an instrument. So do transfer the concepts to other dimension. In the next video we'll start to talk about how to measure time.